Okay. Now I'm going to draw a graph of the basic exponential function where 1 is here, this is -2, this is 2, and the graph looks like this. So this is y equals 2 to the x. Just to make sure we understand how to look at other exponential functions. If we have, well, your first problem was if we have this function. Okay, what's the equation of this function? Well, this is going to be y equals 2 to the negative x. One way to see this is if we take the table for y equals 2 to the x, right here, and we put these numbers in the opposite order. Well, what we've actually done is we put these numbers as well in the opposite order, even though they look the same. It's like the 2, 4 becomes -2, 4. So 2, 4 becomes -2, 4, and -2, 1/4 becomes 2, 1/4. X has been replaced by -x. Okay, so by these arrows, x being replaced by -x leaves the y value unchanged. In other words, replacing 2 by -2, we still get 4. Replacing -2 by 2, we still get 1/4. So that this would be the graph of y equals 2 to the -x. Okay, we've replaced x by -x. If f of x equals 2 to the x, f of -x is 2 to the -x and you have this symmetry. And I don't want to write that. It's not a symmetry, it's a reflection. Through the y-axis. If you replace x by negative x, you get a reflection through the y-axis. So that would be this function. Of course, knowing the table for this function, and we can verify the table for this function, you also see that the functions are identical. If you have this function, which I should maybe draw in a different color, this is a reflection of the 2 to the x function through the x-axis. So the reflection through the x-axis is negative f of x. So that would be negative 2 to the x. And if you look at the table, if you make all these numbers here negative, so you get negative 2 to the x, it's going to match this graph. Okay, then here's the chalk. Then a graph that looks like this would be a reflection through the x-axis and through the y-axis. So if we reflect the 2 to the x function through the x-axis, we get this, and this function is the reflection through the y-axis of this function. So that would be trying to decide how much to write. Reflection through the y-axis of the negative f of x that would be negative f of negative x. So I did pretty well on that problem, but we want to be clear about how we apply these tests. Okay, well, I don't see anything else here, but just to be as clear as possible, let's go back here. Same situation. Here's our graph of y equals 2 to the x if you have a graph that looks like let's say this. Okay, well, the asymptote here looks like it's a little more than it is between -1 and -2. So let's just say that you estimate, and if there's a grid on the graph, you can estimate it, that this is the line y equals, let's just say -3/2. And then this point for x equals 1 actually, we don't need that point. We can use this point. And let's say this point is x equals -2. So here's -1, -2.
Did you mean to say y -2?
Yes, I did. Thank you.
Welcome.
Okay, so we have y equals -2 here. If you look at this distance here, I need to get rid of this jar so I can see my chalk. This blue distance here then is from -3/2 to -2. So and I said this distance is -1/2, and I've got the arrows wrong. Really, I mean the displacement from the asymptote down here is -1/2. Okay, this indicates that to get this function, you could do the following. You could take half of this function, which would give you 1/2 here. In other words, this point would go twice as close to the x-axis, so you would have half as much. So this will be y equals 1/2. I've written that very small, so it might be hard to read. Meaning that if you multiply all the y values by 1/2, you're going to get a graph asymptotic to the x-axis whose y-intercept is 1/2. And that's going to be useful in constructing this graph. So we take this graph and we take its reciprocal, and we reflect it through the x-axis, not its reciprocal, it's negative. And we're going to get this graph. Okay, so what's this graph? The green graph is one-half of 2 to the x. The reciprocal graph is y equals negative 1/2 of 2 to the x. And then we shift this graph down 3/2 of a unit because the asymptote of this graph is y equals 0. We want to shift it down to where the asymptote is at y equals negative 3/2. So now this graph which I'm going to color code like this. This graph is going to be y equals negative 1/2 of 2 to the x minus the 3/2 you need to bring the asymptote down 3/2 of a unit. Well, that's a bad looking 3. Maybe I actually improved it, I don't know. So there we have it. So these are just the sort of things you can look at on an exponential graph. Mainly, you get the coefficient out in front by how far the y-intercept is from the horizontal asymptote, and whether it's above or below the horizontal asymptote. And then you just shift the horizontal asymptote and you can get the graph of the function. Okay? So, just one example, and that kind of builds on what you've done because you did pretty well with those problems. And I noticed that you did have a small penalty in one of them, so I wanted to address that. Okay. So I think you're in good shape. Do you have any questions?
No, no question.